Today we're going to be talking about properties of logarithms. This is something that you're going to have to know how to do starting now, and that is to condense and expand logarithms. We're going to look at the expansion portion today, and we'll look at condensing tomorrow. Alright, I'm going to go through these properties. I want you to make a quick note, and that is to say, the main rules that we're going to be using is the product rule, the quotient rule, and the power rule. You need to remember these three definitely to be able to solve any of the problems we're going to be looking at. You also need to know a number raised to a log. That one is not as common for what we're going to be doing, but you still need to know it, and we will be using it some. Alright, let's take a look. Log of 1. This says log base a, so any number of 1 is equal to 0. Well, alright, let's look at this. If I have log of any number, base of any number of 1, the answer of this is 0, and here's the reason. If I am to transform this into the exponential version, I take my base, shove it under the 0, so under the other side. So I'm going to have 1 is equal to my any number with my 0 exponent. Now we know that right there, a to the 0 power, any number raised to the 0 is equal to 1. So what this is really saying is 1 is equal to 1. Okay, should be good with that one. Let's move on to the next. This says log base a of a is equal to 1. Once again, let's convert this into our exponential. We have a is equal to a to the first power. A to the first power is just a, so we literally have a is equal to a. So of course, this is true, it's just going to be equal to 1. Log base a of a is just 1. Okay? Now, of course, you have all these properties written down already for you, so you can go to them as needed. But I'm going to give you some examples and show you what they're saying. Starting first, product rule. If I have log base a, so any number, of, and then two numbers being multiplied, or two things being multiplied, this is equal to log base number of the first multiplication number plus log base a of the second multiplication number. So here's your example. Log, I'm going to choose a base of 3 for no reason other than because I wanted to. Let me erase that line just to make it a little bit easier for you to see. Log base 3. And what I'm going to be given initially is going to be 4x. It is imperative that we see this as not just 4x, this is 4 times x. We understand that there is a invisible multiplication symbol in between the 4 and the x here. Well, according to our rule here, I'm going to take log, again, base 3. I do want you to notice real quick, the reason why it's base 3, this base is 3. I never change the base. It'll stay the same thing throughout the entire expansion. Of my first number, plus log, again, I'm looking back to the base that I started with, or a 3. So log base 3 of my second number. And now I'm finished. Let's look at the second one. This is your quotient rule. Log base a. All right, I'm going to put a different number here. I'm going to just put a base of star. Why? No reason, just because I can. Doesn't matter what the number is. Whatever you want to put, you can write down. All right. Let's use 7/5. This is going to give us log my star, or my base, my first number, which is 7 on top, minus this time log base star of my second number, 5. Power rule. If I have log base 2 to the 4th power with an exponent of 3, okay? So this is log base 2 of 4, and then that's raised to the 3rd power. I can take my exponent here, it's a little bit thick. I can take my exponent here and put it in front of the logarithm. So this is 3 times log base 2 of 4. Okay, and I'm going to show you one that you're not going to have to use because of Desmos. The change of base rule, if you have log of 7 over 3, or 7 of 3, in the old calculators like you have hanging on the wall in most of your classrooms that you've had in math, you cannot type this into the calculator. It won't let you because you cannot change the base on the log. Real quick, let me remind you. If you have log of z, this is the same thing as log base 10, and you have to know this, of z. If you do not see a log base number, it is going to be 10. These are the same thing, okay? But anyway, it can only do log base 10 in calculations. So what you would have to do is put your log of the first number, 3, over log of the second number, 7. That's how you'd be able to get the actual quantity you're looking for. However, you have Desmos. For Desmos, you're going to type the letters. I'm going to go ahead and write this for you. You're going to type LOG. Type log. And then you're going to hit glad I ain't an English teacher because I sure can't spell sometimes. And you're going to hit Shift Shift and then minus. This will give you the subscript to put in your base. So you're going to type in your base. Then you're going to hit right arrow so that you can get your number put in. Okay? All right. I'm sure you'll be able to remember this. If not, write it somewhere on your paper just so you know you're going to type in the word log, shift minus, then you type in your of number. It will give you the computation like we did yesterday. All right, equality rule. If I have log base 80 of x is equal to log base 80 of 21. Since I have log base 80 is equal to each other, your log base 80s cancel. So what I really have would be x is equal to 21. I am going to show you why here in a minute. But for that, it's the rule that you need to know. And that is a number raised to a log rule. So if I have any number 4 to the power of log, and then the base has to be a 4. Okay? So this base and this base are the same. My answer then is just the thing inside the parentheses, which would be x. So the log base 4 and the 4 on the base of the exponent cancel. Only thing I have remaining is x. The reason why it works for the equality rule up top, because I'm going to have to use what I just wrote down. If I had the log base 80 of x is equal to 21, or log base 80 of 21. If I were to convert this into an exponential, I'd take my base 80, shove it under the log. So x is equal to 80 to the power of log base 80 of 21. From the power raised to the power rule that I just showed you, the 80 and the log of 80s cancel. X is equal to 21. That's why it works. Okay? You don't necessarily have to know why, but then again, it might help you. You can look at the other rules. Honestly, you're not going to be using them, so I'm not going to spend your time using those. All right. I'm going to encourage you to do 2 things. If you are ready now, and we're going to work to number 12, but if you're ready now to use these rules to expand the logarithms, go ahead and pause this video and try them. Then I'm going to work 2 for you, maybe 3. And from there, we'll see if you have any questions. And then I'm going to write up the answers for the rest. Okay? Okay. Let's look at numbers 3, 4, 5, and 11. So I'll do these 4. You do the other 8 for practice. All right, number 3. The first rule I need to use is my power rule, because of the 5 is on the outside of these parentheses. Okay? The power rule, I'm going to write down power rule, says I'm going to move the 5 in front of log. So this is 5 times log, and then 6 over 11. Okay, now I'm dividing in the log. That is my quotient rule. Quotient. So I'm going to have 5 times, and I need to put a parenthesis here, log of 6 minus log of 11. This answer is completely sufficient. However, just because I guess you can say I want to be hateful, I'm going to say we're not done here. I want you to distribute that 5 to both of your logs. And then we'll be done. So, I'm going to say 5 times log of 6 minus, I'm going to go ahead and draw the arrows just so you can see what I'm doing. 5 times log of 11. Okay, I'm done with that one. Number 4. In this step, I do have an exponent, However, this exponent is not on my parentheses, it is just on my 2. So my first step is not the power rule, but it is the product rule because of that multiplication symbol. So product rule. And I'm going to say log of 3 plus log of 2 to the third power. Now I can use my power rule. So this is log of 3. Didn't change anything there. Power rule, I'm going to take the 3 and the exponent on the second logarithm and move it in front of log. So 3 log of 2. I'm done. I want you to notice what happens. That's different between 4 and 5. And 4, the power rule was first, which means my answer, the final expression, needs to have a 5 on both logarithms. On number 4, only the 2 had the exponent on it, so just the log of 2 part is what had the 3 times. Okay? So to recap, and I'm going to write this out, and instead of doing number 5, I'm just going to write it out for you. I wrote the number 1 trying to put if. If the exponent is on parentheses, I was going to say both, but I'm going to say all. All logs get the exponent in front of them. So how do I want to write that? Let's say the exponent number on the front. Okay? And if it's not in the parentheses, it just goes to this one singular number. All right. Let's do number 11. I'm going to let you practice. So number 11, we have log of the cube root of x times y times z. I'm going to change this to become a power. This is log of x times y times z to the 1/3 power. Okay? So this is 1/3 times log of x times y times z I got that from the power rule. Now I realize this is different because you have 3 variables or 3 numbers inside the log. However, our steps are not changing. This is just the product rule since all 3 of these are connected through multiplication. So this is 1/3 times log of x plus log of y plus log of z. Now, like I said, you can distribute this 1/3 to everything, and I'm going to do that. But if you don't, as long as you have the parentheses grouping the whole entire expression here and here, you could be done. But now, 1/3 log of x plus 1/3 log of y plus 1/3 log of z. There we have it. We're done with number 11. Now, I want you to pause the video, and we're at number 1, 2, 5, 6, 7, 8, 9, and 10, and 12. Go ahead and pause it. I'm going to give a minute. Then whenever you unpause the video, you can go and check your answers. I'm going to start working them out. Well, I'm not going to work them out. I'm just going to list the answer. And I do encourage you to put the power product or quotient rule just to help you. But anyway. All right. Now I'm going to start working them out for you and give you the answer. Log of 6 plus log of 11. Log of 5 plus log of 3. For log of 2, notice there is no parentheses between the 4 and the log, and whenever I say minus log, there's no 4 on that log. Again, the reason being, the 4 was just on the 2 as an exponent, not in parentheses. This one does have parentheses, so they both get it. So 6, that's a bad 6. 6 log of 6 minus 6 log of 5. Quotient rule, power rule, power rule, then product rule, quotient, then power, quotient, then power, product, then power. Okay, we are done for the day. I hope you have a great rest of your day.